Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is mean value theorem problem solving. In this video, we are going to see how to apply mean value theorem in problems and solve them. Let's have a brief recap on the mean value theorem. For more detailed video on mean value theorem, you can refer our previous video. So the statement says, let f be a function that fulfills two hypotheses. F is continuous on the closed interval and f is differentiable on the open interval a comma b. And this is the formula for the mean value theorem. The first derivative of the function f of x, f dash of c is equal to f of b minus f of a over b minus a. Or equivalently you can say this. This is just the cross multiplication of the formula. Both are applicable for the mean value theorem. Both are same actually. One should know the value of the mean value theorem. The mean value theorem actually it expresses the relationship between the slope of the tangent to the curve at a point x is equal to c. The slope of the secant to the curve through the points a comma f of a, b comma f of b. Both are corresponding. Now let's see the application in problems. Let me take the first example. In this example, we are supposed to find a value of c such that the conclusion of the mean value theorem is satisfied for the function f of x on the interval -2 to 2. Please look at the given function. This is a polynomial function, right? So a polynomial is continuous and differentiable for all real numbers. So f of x is also continuous and differentiable for all real numbers. So let us evaluate f of x at the bounds -2 and 2. So you just have to replace this x value. So replacing by 2 and -2, you have to check what value you are getting. So let's do that step first. When x is equal to -2, I have to replace all the x's by -2. So I get 2. Please check whether you're getting the same value. Very similarly, you have to replace x by 2. So by replacing, I get -6 when I simplify this. Now we are going to evaluate f of b minus f of a over b minus a, the definition for the mean value theorem. F of b is f of -2, f of a is f of +2, the interval given. So by plugging in those values in the definition of mean value theorem, we will get replacing f of b by 2, f of b by -6 and f of a by 2 and b minus a. So 2 minus minus of 2. So there is already a negative sign here. So please be careful while doing that. You have to be familiar with the rules of sign while doing this operation. So I get, -8 over 4 is -2. So far we have calculated the one side of the mean value theorem, the right side of the mean value theorem. Now we are going to work out the f dash of c. Because we are going to do both the sides of the mean value theorem and check what is going to happen when we take first derivative of the function f of x. This is the given function f of x. F dash of x is nothing but first derivative of this function. So if I apply this, I have to apply power rule here. So -2 times 3x square. So -2 times 3 is -6. So it means if I find the first derivative of the first term, I'll get -6x square. Same way, if I find the first derivative of the second term, it is just 6 times 1. So 6. Derivative of the constant is always 0. So just ignore that. We have got the value for f dash of ex. We now construct an equation based on the mean value statement. I'll just write the formula. Here is our mean value theorem formula. For f dash of c, just plug in this expression. Instead of x, we are going to plug in c. And for the right side, we have got -2. If we shift all the terms to one side of the equation, we'll get a quadratic equation, right? If of the form ax square plus bx plus c. So let us create a quadratic equation and factorize that and solve for c. Since the c term is missing, we can directly solve it. So no need to apply factorization here. So divide both sides by 6. So you'll get taking square root on both these sides. Since this is a quadratic equation, you have to mention a plus or minus sign before the square root of any positive number. Okay, square root of 4 is nothing but 2. So you can take this outside. So 2 times square root of 1 over 3. Solving for c, we got two solutions. C equal to +2 times square root of 1 over 3 or -2 times square root of 1 over 3. It is always advisable to give the graph for this one. So it is very good to mention the graph and mention the point C on that graph, mentioning the tangent too. So below is shown the graph of f, a secant and a 2 tangent. It corresponds to the two solutions found. The secant and the two tangents are parallel since the slopes are equal according to the mean value theorem. That's it for this example. Hope you're clear with this example. Okay, now let us move on to the next example. Here is the next example. Please read the question once. We are supposed to use the mean value theorem to prove that for any two real numbers a and b, absolute value modulus of cos a minus cos b is less than or equal to a minus b. Okay, here we are given with a trigonometric function cos x. First, when you are asked to use mean value theorem, you have to check whether the given function is continuous and differentiable. If it is continuous and differentiable for all real numbers, then it is easy for you to apply the mean value theorem because the statement of the mean value theorem says so. Am I right? So in case if you have any query on mean value theorem, you can refer a previous video. The function cos x is continuous and differentiable for all real numbers. So let us use the mean value theorem using the two real numbers a and b to write. This is the formula for mean value theorem. So I'm going to apply the same concept here. F dash of c. So I'm going to take the first derivative of the function cos x. And here cos a minus cos b divided by a minus b. I'm going to use the same concept. It is given in this order, a minus b. So I'm going to follow the same concept here. I'm just using the function cos x. In the place of f, I'm using cos x. So first derivative f dash of c is replaced by cos x first derivative, which is equal to cos a minus cos b divided by a minus b. Can you follow so far? Now take the absolute value of both these sides. The steps I'm following are not the rules. We are just following the given statement. So based upon the statement, based upon the need, we are just using the steps. So in the question we have absolute value. So I'm using absolute value. That is my next step, taking the absolute value on both the sides. So what is the first derivative of cos x? If you have a glance over the formula set, you can understand that. So first derivative of cos x is nothing but negative sin x. So I'm just going to use that. And also we know that first derivative of cos x is less than or equal to 1. So I'm going to use the two concepts here. So which gives cos a minus cos b divided by a minus b is less than or equal to 1. Am I right? But the left side, cos a minus cos b over a minus b, you have written absolute value on the whole. This can be written as absolute value of cos a minus cos b divided by absolute value of a minus b. We can just split it as we do in the square root. Next step is obviously we are just going to cross multiply. By cross multiplying we'll be getting. That's it for this example. Hope you're clear with this function, trigonometric function cos. Okay. So far we discussed application of mean value theorem in polynomial function and trigonometric function. Now let me take one more example. Here no particular function is given. Some clues are given and we are going to apply the mean value theorem here. So suppose that we know that f of x is continuous and differentiable on a interval 6, 15. So continuous and differentiable means obviously we are going to use mean value theorem. Let's also suppose that we know that f of 6 is minus 2. First we have to take down all the given information. Now the question is asking us to find what is the largest possible value for f of 15. Okay, let's start with the conclusion of the mean value theorem. We know the mean value theorem, f dash of c is equal to f of b minus f of a over b minus a. I'm going to use the same concept here. In the starting of this video, I showed two equations by cross multiplication. I'm going to use that concept. I have just cross multiplied and swapped the sides. So in the place of f of b, I can use f of 15. F of a is f of 6 here. And f dash of c is the same thing. B minus a is 15 minus 6. So by replacing all those values, all the given clues in this equation, I'll get. Now plugging in for the known quantities and rewriting this a little, we'll get, I'm just going to shift this to the right side of the equation. And 15 minus 6 is 9. Okay, so it can be written as a coefficient. It is already given in the question. We know that f dash of x is less than or equal to 10. So in particular, we know that f dash of c is less than or equal to 10. I'm going to use this. So this gives us the following, f of 15 equal to negative 2 here. And this would be 10. So I'm going to change this as less than or equal to symbol. Let me do that step by step so you'll understand this better. Plugging in the value of f of 6 Now applying the concept f dash of c. F dash of c is less than or equal to 10. So if I simplify this, I'll get 90 minus 2 is 88. All we did was replace f dash of c with its largest possible value. This means that the largest possible value for f of 15 is 88. Does this make sense to you? Let me close this video out with a couple of nice facts that can be proved using the mean value theorem. Note that in both these facts we are assuming the functions are continuous and differentiable, the very basic condition of for application of mean value theorem on the interval a comma b. The first fact is, here are the two facts. The fact 1, if f dash of x is equal to 0 or all x in the interval a comma b, then f of x is constant on ab. If f dash of x is equal to g dash of x for all x in an interval a comma b, then in this interval we have f dash of x is equal to g of x plus c, where c is some constant. Please notice that for these two facts, we have to assume that the functions are continuous and differentiable on the closed interval a comma b. Hope you are clear with problem solving mean value theorem. We have so many examples on this topic. I picked up the important functions and one general example. In case if you get any questions,